Alright, hello. Today we're solving linear systems with three unknowns. So you could pause this video and try the problem and then come back and see how well you did. So what we have here is we have three unknowns. We have x, y, and z. We have three equations and we should number them. So if we reference them, this is number 1, equation number 2, and equation number 3. And the first thing I want to do is I want to pick out one of the unknowns to eliminate. So there's a lot of options here. I'm going to choose y here to eliminate. I see that we have a negative y here and a positive, so if I add these two equations, those y's will drop out, so that's nice. And then I have, let's say, a positive 4 and then something here that I would love to see a negative 4 there, and I think I can transform this equation number 3 into something that works. So we start by going through and adding two of the equations together to drop the y out because we chose y to eliminate. So I'm going to go over here and I'm going to add equation number 1 to equation number 3 because I see that the coefficients here, positive 1 and negative 1, are opposites, and that's what I need. So let's take equation number 1, and there we go, and we add it to equation number 3. So I'm really looking to get down to where I have two equations and two unknowns because I can more easily solve that. Hopefully easily solve that. So what I have here is I'm basically just adding down the columns here. I have a 9x. The y's will eliminate or drop out there to 0. And then I have a negative 10z. And just be careful here, but this should be a negative 25. So this equation down here is one of the two that I will use when I am going to solve the two unknowns in two equations. Now I need to add two other equations here, but first I have to do something with this. Now I like the negative y here, negative 1y. This is a positive 4, so if I can make this a negative 4, then when I added these together they would eliminate. So what I'll do is this. I will take this last equation here, number 3. I'm going to multiply it by 4 so that when this 4 gets multiplied in, I have a negative 4y that I want. So this is what we'll call the new 3. Okay, and that will be just multiplying this 4 to each, well, 4 of the terms there. So this is the new 3, and the new 3 would be 20x minus 4y minus 28z equals 4 less than 80, 70, and negative 76. Negative 76. Alright, so I'm going to take this, I'm going to add number 2 there, which has the 4y, to the new 3. We'll call it the new 3, and that has the negative 4y. So let's take 2, and just as we're going through this, you want to try to choose to eliminate a variable. If the coefficients are all the same number or plus or minus that same number here, I would probably stick with that. These z's, you have a minus 3 and minus 7 and plus 2. You could work with that, but you're just going to have to be multiplying through a few equations there. It's a little more work. So in this case, the y's look easier to work with. The x's you know could work with, but try to just keep things as simple as possible. So the new 3 now is this 20x here minus 4y minus 28z equals negative 76. So when I add these two down the columns, I'll get 18x. These will drop out. I will have negative 26z equals negative 38, I hope. So what I have is these two equations here with two unknowns, these guys here, this one here and this one here, and I'll just scroll down here and I'll continue on that. Okay, I hope we're back. Here we go. Okay, so I have these two equations here, and I'm going to rewrite these here as 9x minus 10z equals negative 25, and 18x minus 26z equals negative 38. There's a couple options here. Since if I add these together, none of the x nor the z will eliminate. So I'm going to have to multiply at least one of these equations by something. Now, what I could do is do the crisscross here and multiply this top equation here by the 18 and the bottom one by the 9 and then make one a minus, which will work. Okay, so we could do that. But I see that this is a 9x here and this is an 18x. And if this were a negative 18x, I'd be in pretty good shape here. So I'm going to go ahead and multiply this by a negative 2. Although you could put an 18 here and let's say a negative 9 there and be fine as well. Those numbers a little big though. So here we go. We're going to multiply through by the negative 2 because when I distribute here I will get the negative 18 I want. So let's take this equation, all three terms here. This is a negative 18x. It's positive 20z, and that is equals a positive 50. And the second equation would be 18x minus 26z equals negative 38. So when I add those together, these drop out to 0. I get a negative 6z equals, and I think that's a 12. So if I divide by the negative 6, I will end up with a z equals negative 2. Now, often you will get an integer value for your unknown, but you could get a fraction. It shouldn't be a crazy number, we hope. But I have solved for z. So my plan is to get x, y, and z. I have z already, so we're looking good here. I'm going to take this up all the way back to the top for a moment. So I have z equals negative 2. I will plug this into one of my two unknown equations here, and I'll just pick the first one, doesn't matter. And what we'll do there is we're going to plug into the 9x minus 10z equals negative 25. Because if I have two unknowns and I know now one of them, I can figure out what the other one is. So this is 9x minus 10. Use a parentheses there. Times negative 2 equals negative 25. And this is 9x plus 20 equals negative 25. I'm subtracting over, and hopefully I'll have enough room. So we get 9x equals negative 45. Dividing by 9, x would equal negative 5. So I have x, and I have z, and I don't have any more space, but I can probably do this. Alright, hopefully you can still see that, but now we have more room here. So now I have z equals negative 2, I have x equals negative 5, and I'm going to plug these into one of the original three unknowns here. So I'm going to plug into, we'll go with number 1. So here I have 4x plus y minus 3z equals negative 6. We have 4 times negative 5 plus y, which is what I'm looking for, minus 3 times negative 2 equals negative 6. And that gives us negative 20. This will give me a 6. So I'll just put the 6 there, plus y equals negative 6. These combine to a negative 14, plus y equals negative 6. And when I add 14 on both sides, I get a y equals 8. Now, I have my three unknowns. I have z equals negative 2, x equals negative 5, and y equals 8. And we hope they worked there. So what we can do is we can check them. You can check them into all three, but at least one. So let's see if this 4 times negative 5, well, you know what? Let's do this. I just used that equation. So So that one probably should work because that's where it came from. Let's try another equation, like let's use number 2. Okay, just to make sure that it's working out here. So negative 2 times x, which is negative 5, plus 4 times y, which is 8, plus 2 times z, which is negative 2. Z is negative 2. And let's see if that equals the 38 that we hope. So we have 10 plus 32, which is 42, minus 4 equals 38. So it's right. And hopefully this helped. It's a long problem, but step by step it's not so bad. And you really want to be neat in your work, and so that your wonderful teacher can give you the proper credit you deserve. We'll see you soon. Bye.